Okay, next we have the magnetic moment due to orbital motion of electron. First we will define a magnetic moment. Suppose we have a closed loop and an electron is moving in this closed loop and this closed loop has an area A. So once it's moving in this closed loop, then there is an electric current due to movement of this electron. So the magnetic moment mu, which is represented by this symbol, which is equal to the current flowing through a closed loop of area A, is called magnetic moment. Now we have to explain it. Here we have the explanation. Suppose we have an electron which is moving in elliptical orbit, because electrons are moving around the nucleus in an elliptical orbit. This is an elliptical orbit and this is one of the foci where we have the nucleus N. And this is the same image here exists. Suppose the electron at time t is somewhere here at point M, and after some time t plus dt, this electron reached to this point O, let's suppose. So here we have the angle phi and here we have the angle d phi. Now this is the arc length, which by this definition is equal to r theta is r d phi. This is the arc length. Now this electron which is moving through any point with cross-section area A, which is equivalent to the current flowing through that point, and we know that the current is defined by this relation E over T, charge flowing per unit time in a unit area. Now putting this value in above equation, we have the magnetic moment value is EA over T. Here I will introduce a symbol C, which is the ratio of two kinds of unit, where C is the ratio of EM unit to ES unit of electron, of charge. So this is my equation number 1. Now the area swept by this electron in one revolution, like if an electron started from point M, complete one revolution and reach to this point M again, the area swept during this one revolution is basically the area of this elliptical orbit. Now the differential area of this, I will write it again here. This is the same image exists. We have the nucleus here, electron move from point M to point O. Now this differential area, this differential area which I call dA. The total area is A of this loop. So the differential area dA is basically the area of triangle MNO, and we know that the area of a triangle DA is equal to 1 over 2 r times the arc length, which is r d phi. So the differential area will become 1 over 2 r square d phi. Let this is equation number A. Now since electron complete one revolution in a time period of t, because we have the time period t, in one revolution, so the area swept during this one revolution is basically the area of the elliptical orbit, which can be calculated by integrating the above equation. So integral of dA, like I will integrate both sides of this equation, 1 over 2 r square d phi. So from this side we get the total area, which is equal to 1 over 2a is constant, so I'll keep it outside of the integral, and we have r square d phi. This is the total area of this closed loop. So it's a closed loop. I will use this closed integral, and the limits are, because we have this, the variable is this phi. So, and we know that in spherical polar coordinate system, phi has a limit. The phi limits are changing from 0 to 2 pi. So the limits of the integral are from 0 to 2 pi. Now, equation A can also be written as, let's suppose this is equation number 3, I think. This is equation number 2, yes. So equation A can also be written as, we have equation A, dA, which is equal to 1 over 2 r square d phi. So I divide both sides of this equation by dt. So here I have dt. This is, let's say, equation number B. So it means that similarly equation 2 can also be written as, equation 2 can also be written as A is equal to integral of 1 over 2 integral of 0 to 2 pi integral of r square d phi. So I'll multiply and divide this side by dt, which is equation number 3. But we also know that the angular momentum of electron, which we represent by Pfi, is, according to Bohr's second postulate, I think angular momentum is equal to mvr. But we know that v is equal to r omega. So Pfi is equal to m r omega into r. So Pfi is equal to mr square omega. And omega is the angular velocity. Omega is the angular velocity, which is equal to the rate of change of angular displacement d phi by dt. So Pfi is equal to mr square d phi by dt. This is angular momentum. Now from Kepler's law, Kepler's second law says that the aerial velocity of a particle moving in elliptical orbit is constant.